Hello everyone, my name is Dr. Abhishek Kumar and today I'll present my e-lecture on automation and IoT for digital agriculture. On this topic we'll be discussing. Let's begin. So these are the contents which we'll be discussing in the upcoming slides. So first will be the introduction, then key components, applications, advantages of the microcontroller based systems. Then we'll be discussing the 4 setups which can be used for digital agriculture. First will be the digital distance meter, and second is the mobile app based irrigation pump controller, and then third is the IoT based cloud computing for AI modeling. Fourth is the microcontroller operated automated polyhouse. Then challenges and future prospects, and then acknowledgements. Okay, so let's begin. So introduction. So these are the 2 basic terms that is used in the field of you can say IoT, AI, so digital agriculture. So the first is automation. Automation is what that reduces human intervention. It automates the things. It can be done with the help of multiple kinds of sensors available, and then the actuators, then the robotic arms, then the use of machineries, which will enhance the efficiency and productivity. Then second term is the IoT. IoT is the full form. The full form is Internet of Things, and it basically it is a system that is used to interconnect many devices at a time, or use the internet for cloud computing, cloud storage, storing the sensors data on cloud, the real-time data analytics can also be performed using the IoT. So this is the basic introduction of the basic terms automation and IoT. Then automation and AI that would revolutionize agriculture by getting means multiple applications for this IoT and sensor based automation setups can be done. So first one is smart irrigation. Suppose some moisture level, on the basis of moisture level the pump controller can be switched on and off, or we can measure real time soil health in terms of NPK. Real time weather monitoring can be done. Cloud based uploads can be done in weather monitoring, different parameters such as soil moisture, you can say soil temperature, wind speed or wind velocity, wind direction, relative humidity, temperature, rain. These all things can be collected through various sensors, and it can be uploaded to the cloud, and that data which is collected over time, that can be used for formulating farming models. Then smart greenhouse can be made, like say 4 sensors are there, say relative humidity, temperature, light intensity and soil moisture. So on the basis of that it can be automated. We will talk in our smart greenhouse section, which is in the upcoming slide. And similarly drone monitoring can be done, which can be used for early disease detection. So let's move to the next slide. Key components of IoT in agriculture. So basically there are 4 components that IoT, Internet of Things, if someone wants to make IoT devices, is needed are the 4 basic things. So first one are the sensors. Various kinds of sensors are there. Temperature, RH sensor is there. Then air pressure, wind velocity, wind direction sensor is there, soil moisture sensor, soil temperature sensor. Then air quality sensors are also available, which these sensors can be used to record the real time climatic data, and it can be connected. Second one is the connectivity. So it can be connected via Wi-Fi or Bluetooth or any cellular network modules like SIM 900A, SIM 800A, and it can be uploaded to the cloud. And then third one is the cloud storage. So it will be the first the sensors collected the data. It was the connectivity was done via Wi-Fi, you can say, in terms of if we talk about cloud storage. Then the data for the 8 sensors got stored on the cloud. Okay, say 8 sensors which I mentioned above. So it got stored on the cloud. Then analytics can be done, like MATLAB visualization for different kinds of data, different kind of boundaries can be put, and then we can obtain the desired results. And on the basis of the data analytics, actuators can be switched on or off, like irrigation pumps can be switched on and off, ventilation fans in a polyhouse can be switched on and off. And the thing is that the electrical appliances which will be switched on and off can be of alternating current nature type or DC current and direct current nature type also. So now, so these are the basically 4 components. We'll move to the next slide. So these are a few, you can see the components which we use. So first one is a breadboard. See, the 3 kinds of jumper wires are there. Then button caps are there. LED resistance is there. Then these are different kinds of components which is used in automation, IoT, and AI for digital agriculture. So this is one kind of sensor is the ultrasonic sensor, which measures distance, and it can be used for a variety of purposes, including measurement of plant height, which will reduce the involvement of laborers. So we will see that in detail in the next upcoming slides. Motion sensor for detection of intruders on farm, then temperature sensor for measurement of soil temperature, then RFID kit for security purposes, then touch sensors, piezo buzzer, water sensor for sensing water, many soil moisture sensor for measurement of soil moisture, real-time soil moisture can be measured, light sensor can be used in case power lamps have to be actuated, that is photosynthesis active radiation lamps that are installed in polyhouse for providing artificial photosynthesis. So then this is the kind of OLED display used to, that is the LCD display, just used to display the readings of the sensors. Then you can see the keypad, then IR remote control kit, which can be used to control various devices, and relay, the most important thing that is used to actuate solenoid valves, maybe, which you can see here, solenoid valves, irrigation pumps, or any kind of electrical appliances can be actuated with the help of relay. So this is a kind of relay. We'll move to the next slide. Applications of IoT in agriculture. So we have lot of applications that can be performed with the IoT, Internet of Things. Smart godowns can be made, like automatic RH, relative humidity and temperature, can be controlled to stop the spoilage of grains. Like you see, say if RH, if we do some programming in the microcontroller, and if the RH raises beyond some certain limit, what is pre-programmed, say 70%. So then automatically the exhaust fan or the ventilation fans will be switched on with the help of the relay that we saw in the previous slide. So with the help of that, RH can be reduced. Again, if temperature is less, if much more temperature is desired in the godown, then the microcontroller, if say the temperature needs to be below 15 degrees Celsius, and if it goes, the temperature raises to 16, automatically the microcontroller, the sensor will sense the data and send it to the microcontroller, and the microcontroller will actuate the relay, which will again actuate the blower, the heater, which will be used to raise the temperature of the go down, and as soon as it will reach 15 degrees Celsius, which was desirable, automatically the blower will switch off. So this is one of the applications which IoT has, with the help of IoT, which can be done. And second is smart irrigation system. So automated irrigation based on soil moisture levels can be done. Soil moisture, if it is less, automatically the motor, the pump will switch on, and if it is the soil moisture level is more, it will switch off. Weather monitoring. Then weather monitoring, we discussed earlier that the different parameters for weather, like temperature, relative humidity, soil moisture, soil temperature, then wind direction, wind velocity, these all parameters can be monitored and uploaded to the cloud, and further analysis can be done for the real time data. And with the help of IoT, we can even upload the data of the 8 sensors every 15 seconds, and that huge data, which will be collected over years, can be used for the framing of the farming models. Then smart greenhouses, IoT based climate control for enhanced plant growth. In this smart greenhouses, we can use various kinds of sensors: RH, temperature, soil moisture, light intensity, pH, EC, pH, acidity or basicity, that represents acidity or basicity, and then EC, electrical conductivity. These all things can be controlled in a smart greenhouse. Then drone based field monitoring can also be done for early disease detection. So we'll move. Advantages of microcontroller based systems. These systems can be used to run small loads to heavy loads too. Means it can be used for 1 HP pumps also, 2 HP or even 5 HP. Relays of different current amperes are available, ranging from 10 amperes to 20 amperes to 50 to 100 amperes even, and can also be used to run AC and DC appliances both. Low power consumption, second is the low power consumption, very less, the automation part takes very less power, it can be in the range of around 10 watts only. So it can be run on mini solar panels too. Lightweight, the microcontroller setup is very lightweight, excluding the actuators. So the automation part, that the setup is very lightweight and very less space is needed, and the replication takes very less time. And say some parts gets damaged, so the parts replacement is also very easy. Mobile app is user friendly, that can be used by the farmers very easily, and it is very easy to install it at the electrical boards by simply removing the manual switch and replacing it with a relay, and it is of very low cost. But so many advantages are there, but what lacks is the lack of programming, language. That is the key to the IoT or automation or AI. 10. Now we will discuss all 4 devices one by one. So this is the first device, that is the digital distance meter using microcontroller, and this uses a ultrasonic sensor. You can see this is a ultrasonic sensor, that is HCSR04, and it emits that is ultrasonic waves, and the frequency being 40 kilohertz. So we are unable to hear the sound because our ear can hear only in the range of 20 to 20,000 hertz. So this ultrasonic sensor that emits ultrasonic waves. The waves travel and hits the obstacle and comes back. The time taken for the wave to reach the obstacle and come back and hit the sensor back, that time is recorded, and speed of sound is known for a given temperature and pressure. So with the help of that, automatically our distance can be calculated, and the same formula is used for calculation of distance. And this is the data, the distance can be stored in the SD card module, and this is the microcontroller and is the LCD that is used for display of the distance, and it can be demonstrated in terms of centimeter, inch, feet, anything, whatever is desirable can be programmed. And this is the real setup of the distance measuring sensor. So this was it, and the working principle that emits high frequency sound waves, and it hits the object and returns, and so the microcontroller calculates the time, and it is converted into distance. Applications in agriculture can be for obstacle detection, for agricultural machinery, monitoring of crop growth parameters such as plant height. So plant height, that for measurement of plant height, the digital distance meter can be used, and that will reduce the human intervention for that takes time, that take a lot of time and resources. So it can be used by our researchers for plant height measurement too. And water level monitoring in reservoirs, ponds can be done, and automatically relays can be actuated on the basis of the readings. Advantages are very cost effective and easy to deploy, high accuracy and real time measurements, and low power consumption for sustainable use. So high accuracy, the ultrasonic sensor, that accuracy is 0.2 centimeter, and so it is very you can say accurate. So this is the programming we are talking about. So the programming is in C++ language, and this programming is for the digital distance meter. And first we have done the declaration of data type, and then we will include that liquid crystal I2C .h library for we'll include this library for the LCD to work. And then pin mode, we have just defined the pins, the echo and trig pins as output and input. Then LCD.begin, the LCD will start, LCD backlight, the backlight will glow for that, and then void loop starts. And then we will write all the logic. So this is the main logic what we discussed earlier, that is distance is equal to duration multiplied by 0.0346 divided by 2. Now we'll learn this formula, why it is 0.0346, because it is calculated in centimeters per second. So the distance what we'll obtain is in centimeters, and divided by 2 is done because it is the ultrasonic waves that are coming out of the sensor, hitting the obstacle and coming back again to the sensor. So the distance travel is doubled. So what the thing is that it should be divided by 2. So simply we will display the readings with the help of LCD and serial monitor too. So this is a view of the software, that is Arduino 1.8.19 version, and it can be used simply with the help of upload button. In a single click, the programming can be uploaded to the microcontroller and your device is ready to use. So we'll move to the next slide. This is the second device, that is mobile app based irrigation pump switching. Simply what we are doing in this is we are switching on and off whatever electrical appliances are connected, like say in case of farming, we can do switching of the irrigation pumps with the help of our mobile phone app around from India, anywhere in India, around the world, around the globe. You can do switching of your electrical appliances like irrigation pumps. So we will see, and the various connectivity modules can be used. Even Bluetooth modules can be used in case we want to do switching in the range of 10 meters around, and Wi-Fi modules must be used if we want to do switching from around the globe. So working principle is simple. The mobile app sends a command to the microcontroller, the ESP8266 in one case, and that is used for that the microcontroller activates the relay and the irrigation pump is switched on or off. Application in agriculture, so farmers can operate the pump from anywhere using a smartphone, and this will save their time, which can be devoted for their other works, energy, water and time conservation. This can be done with the help of this device, and it can be also integrated with IoT soil moisture sensor. So if the soil moisture is reduced, the pump switching can be done. So this is the programming for this device, and simply we have means declared the relay pin as third pin, and the comments are given here also to explain the lines separately. So the relay pin is the third pin, and so on the microcontroller the relay signal pin must be connected to the third pin. Then in state, then void setup, simply we have serial.begin means that is 9600, that is the baud rate, and void loop. So void loop started and the programming it is started, and this is the next programming means continuation of the earlier slide. So if state is equal to W means this W, this capital W, we have to feed it in the mobile app. So in the mobile app, capital W must be feeded, and if it will then match with the microcontroller, the mobile app will be connected to the microcontroller and it can be used for actuation of the relay. Okay. So this is the third device, is the IoT based cloud computing for AI modeling, and this can be used to store various kind of data, upload various kind of real time data that can be used in future AI farming. So in this example we have used one sensor, that is DHT11, that is used to measure temperature and RH simply, and the data is uploaded to the cloud. The working principle is simple. The data is collected by the sensors and is processed by the ESP module and is communicated to the cloud, and it is stored there. So in this case we have used the cloud server ThinkSpeak, and so the data that is uploaded every 15 seconds or 30 seconds or whatever will program, it's up to us. So that data can be accessed from anywhere around the globe, and we can access it on a laptop, on a mobile phone. So this can be done, and further analytics can be performed. Application in agriculture. So what we can do is monitoring the greenhouse conditions and preventing too much of temperature or RH stress in crops by early monitoring, then enabling remote farming, farm monitoring and automation. So, and also this can be used by students, researchers and scientists of various fields. So how students and researchers can use it, that manually, with the help of this setup, the manual recording of the sensor data, that is RH and temperature can be avoided, and this can be deployed on the fields, which will save the time which can be devoted for some other work. Okay, so then this is the programming for the IoT based cloud computing. In this, simply this is the starting part of the programming, and say I have the full programming for this with me, and if I give the programming to someone else, how that person will use it. So we need whoever takes the programming will need to change three things. That is, one is string AP, that is the Wi-Fi SSID, string pass, that is the Wi-Fi password, and then string API. That API will be generated from the ThingSpeak cloud server, which we will see in our next slide. So these are the three things one needs to change and can access. Then this is the example of our that ThingSpeak. So ThingSpeak cloud server, you can see it was used, and then this is the temperature data on the left hand side, and the RH on the right hand side, and continuously every 15 seconds the data is being recorded and stored on the cloud. So on that only many options are there from where you will get the API key. The API keys option is there. He generate new write API key is there, and this key can be copied and then and pasted in the program, and simply uploads can be done, and the device will start to work, and the IoT device is ready to use. Then this is the fourth device that can be used in digital agriculture. So it can be used for means you can say like four sensors, basically four sensors can be used, like RH, temperature, soil moisture, and light intensity, which can be used to control the polyhouse environmental conditions. So we will discuss it one by one. Like in case of temperature, if we need more temperature, blower can be started, switched on and off. If we need less temperature, automatically the air conditioning system can be switched on and off. Then RH, if RH goes beyond a limit, then exhaust fan will start, or the ventilation fans will start and will continue to run till it reaches the desired level. And if the RH is less than desired, the foggers that will start and will increase the RH. Then soil moisture, the soil sensor will sense the data, and if the soil is dry, motors will automatically start, the irrigation pumps will automatically start, and if the soil is wet, then automatically the relay will be switched off, the motor will be switched off. Similarly for the light intensity sensor also, if during night time as it gets dark, the power lamps, the photosynthesis active radiation lamps, that will glow, and as soon as sunlight comes, that automatically the power lamps will switch off. So we with the help of this microcontroller and IoT based systems, we can automate the polyhouse, which can be used for cultivation of different crops that by changing the environmental conditions of our polyhouse, different crops can be grown at different places. Working principle, we discussed it. So then application in agriculture, maintaining greenhouse conditions to maintain optimal crop growth, preventing temperature and humidity stress in crops, enabling remote farm monitoring and automation. Then we'll move to the next. This is the programming, and this double slash this represent the comments line. So each line is explained. So what are the what is the meaning of each of the lines? So the first you can see the DST pin is defined, that is used for the DST 11 sensor, or DST 22 can also be used for RHN temperature. This is the light pin for light intensity sensor. Then this is the soil pin for soil moisture sensor, and then 3 relays have to be there, and one is for the fan, second is for the power lamps, and third one is for the motor for operating the irrigation pump. Then the threshold is needed to be defined, which the threshold is determined after a series of experiments, that at which threshold level the means what is desired according to the crops, and this threshold can be changed for each of the crops. So this is the next slide, and so simply we have just defined the DST and then the liquid crystal LCD display for displaying of the sensors data, the 4 sensors data, and this in this void setup loop, not loop exactly, void setup section, we have just defined the LCD. Then this is the void loop, and in the void loop the float temperature DST.read temperature is, this line is used to read the temperature value from the DST sensor, and the float temperature, the float is used so that it gives the value in decimal also, or integer can be used in case float or decimal is not required. Then serial.print temperature in degrees Celsius, then humidity in percentage, light intensity in percentage, and soil moisture. So this is the command for printing the various values for the 4 sensors. Then display sensor readings on LCD. This programming lines are for displaying the sensor values on the LCD screen, that is a portable 16x2 screen. Then this is the basic programming what we discussed earlier, like if humidity is less than threshold, then automatically what will happen, that the fan relay will start, else the fan relay will be switched off. Then in second line, the light intensity, if it is less than the light threshold what we earlier defined in our program, then automatically that power lamps bulb will switch on, otherwise it will be switched off. Then similarly for the soil moisture, if soil moisture is less than the threshold value, the motor, the irrigation pump will switch on, else it will switch off. So it is very basic. We have used if then else for this whole programming, the polyhouse setup, and the delay is for 10,000 milliseconds, that for just means 10 seconds or 10,000 milliseconds. So this we have done so that the sensor values do not get you can say bugs, just to prevent the bugs in the programming, we have done it. Then challenges and future prospects. So basically about the challenges, it is that performing automations, making automation devices, IoT devices, doing AI for digital agriculture, all this requires 3 basic knowledge. That is, first is basic physics, second is basic electronics, third is programming language. So these 2, electronics and physics is there, but programming language in depth is required for making of these devices. That is one of the challenges, and digital literacy is also lacking among the farmers, which is also a major concern, and connectivity issues in remote areas. So if IoT has to be used, it needs connectivity, good connection for data upload, and need of skilled support for the repair and maintenance, and for the change of programming, for the change of logic, for the for applications in different crops, different conditions. So that lack of technical support is there, and opportunities like government has taken various initiatives and fundings for investment in digital agriculture. So that is one of the greatest opportunities, and future scope is like 5G enabled smart agriculture can be performed, AI powered robotics for automation, AI and drone based crop management system, and automated polyhouse, automated godowns, automated irrigation systems, digital distance meter, and many others can be performed.